All right, let's dive right in. Today we're talking about a core idea that makes artificial intelligence not just smart, but actually useful. You see, AI has to tackle some absolutely enormous problems. Think about finding the best route in traffic or mastering a super complex game. So how does it handle problems that have a, frankly, astronomical number of possibilities? Well, the answer is a very clever shortcut. Just look at this number, 35 to the power of 80. This isn't just big, it's mind-bogglingly huge. This is roughly the number of possible move sequences in a game of chess. It's what's known as an NP hard problem, where the difficulty just explodes exponentially. So that's the big question, right? How can any computer, no matter how powerful, possibly figure out the best move? I mean, checking every single option, what we call brute force, that would literally take forever. It's just not going to happen. The computer needs a smarter way to work. It needs a shortcut. And this gets us to two totally different ways of thinking about it. On one hand, you have blind search. Think of this as the ultimate perfectionist. It will meticulously check every single path to guarantee the absolute best, most optimal solution. The problem, as we just saw with chess, it can take an insane amount of time. But on the other hand, you've got informed search. This one's the strategist. It doesn't waste time checking everything. Instead, it makes an educated guess to find a good solution, and it finds it fast. That's the million-dollar question, isn't it? How does an AI make a smart guess when it doesn't have all the information? Well, to get our heads around this, let's look at a problem solver we're all pretty familiar with, our own brains. You know, when we solve problems in our daily lives, we almost never use brute force. You don't calculate every possible outcome for your day before you leave the house, right? Of course not. We use intuition, we make assumptions, we use rules of thumb and quick estimates to make decisions on the fly. We're all about taking mental shortcuts. And in the world of AI, these mental shortcuts have a proper name: heuristics. A heuristic is basically a technique designed to solve a problem quickly. It's not about finding the single, absolutely perfect solution. It's about finding a solution that's good enough, right now. So if you need a really simple way to think about a heuristic, just remember this. It's a rule of thumb. It's a guide that points the AI towards a solution that's probably good, helping it avoid wasting tons of time on paths that lead nowhere. Okay, so this all sounds great in theory, but what does it actually look like in practice? How does an AI calculate this smart guess? Let's get our hands dirty with a classic AI problem, the 8 puzzle, to see exactly how it works. So here's the game. On the left, you've got the start state, a total jumble of tiles. And on the right, the goal state, all nice and in order. The AI's job is to slide those tiles around one at a time to get from the start to the goal in as few moves as possible. So how does the AI decide which move to make first? Well, it can use a very simple heuristic. One popular method is to just count up how many tiles are in the wrong spot. The thinking is pretty straightforward. The fewer tiles that are out of place, the closer you probably are to the finish line. And if we apply that to our puzzle, let's see, we've got tiles 2, 3, 4, 6, and 7. Yep, they're all in the wrong spot. That gives us a heuristic value of 5. After the AI makes a move, it'll just recalculate this number for its new options and pick the path with the lowest score. But, you know, we can get even smarter than that. Counting misplaced tiles is good, but it's a little basic. It doesn't tell us how far out of place the tiles are. For that, we can use a more sophisticated heuristic called the Manhattan Distance. The Manhattan Distance is way more nuanced. It doesn't just ask, is the tile on the wrong place? It asks, how many squares up, down, left, or right does each tile need to move to get home? So for example, tile 4 needs to move 2 spots to the left. The AI just adds up all those moves for every single tile to get a much more accurate score. And that number is the secret sauce. The AI uses it as its guide, its North Star. At every single turn, it looks at the possible moves, calculates the heuristic value for each one, and then it follows the path with the lowest score. It's always asking itself, which move seems to get me closer to the goal? But, and this is a really big but, this whole shortcut thing comes with a catch, a big trade-off. It creates this constant battle between finding a good answer and finding the perfect answer. Let's use a navigation example to make it super clear. Imagine you ask an AI for the shortest route to a destination. A simple heuristic would just be to calculate the straight line distance. I mean, the shortest path between 2 points is a straight line, right? So the AI starts heading in that direction. But here's the problem.
What happens when that simple rule of thumb runs headfirst into the messy, complicated, real world? What if the path that looks shortest on a map isn't actually the best one to take?
And this illustrates the problem perfectly. The heuristic confidently says, hey, path A is a straight shot, let's go. But what it doesn't know is that there's a giant mountain sitting right in the way. In reality, path B, the one that goes around the obstacle, is actually the faster, truly optimal route. The heuristic gave us a good idea, but it led us away from the perfect solution.
So this is the fundamental deal you make with heuristics. They are incredibly powerful. They give you a good solution, and they give it to you fast. But what they do not do, what they cannot do, is guarantee the absolute best 100% optimal solution every single time. You're trading perfection for speed. So, you might be wondering, why on earth do we rely on a system that isn't always perfect? Well, it's because this trade-off, this whole concept, is what makes modern AI possible in the first place. Heuristics are the engine that makes AI practical. They take those ridiculously complex problems, remember that chess game, and they turn them into puzzles that can actually be solved. This is the magic running behind the scenes of everything from your GPS navigation to global supply chains to the characters in your favorite video games. And that leaves us with one last question, one that goes way beyond just computers. In a world full of complex choices and not enough time, when is a good enough answer that you can get right now more valuable than a perfect answer that might arrive too late or maybe never at all? It's the essential trade-off that we all have to navigate every single day. Thanks for joining me.